Hi there. The clocks have gone back. I'm in my coat and hat inside the boat, so it must mean that winter is on its way. I've got a little bit of a problem to sort out today, which is that the bilge pump, the automatic bilge pump, is not working properly. It's still spinning, but it's going very slowly. So I'm going to use this as an opportunity to go through how you diagnose an electrical problem on your boat. Hopefully some of you will find this useful. Here's the circuit we're going to be diagnosing today. I've got the 12-volt battery, I've got a switch, I've got a piece of wire, I've got a fuse, another piece of wire, then a second switch. This is the float switch, which turns the pump on when the water gets too high. This is the pump, and then we've got another piece of wire going back to the negative of the 12-volt battery. You can think of this as being like a water circuit where the 12 volts is pumping the water around, and because this is a very simple circuit, the same amount of water or the same current has to go right around the circuit. As we go around, we can check at various points whether we're getting the right voltage, because what we want is all of the voltage to be across here and these things to act as perfect wires, perfect conductors, so that we get no voltage drop. Now, it's pretty easy for me to check this switch and the fuse because they're exposed, but these wires I've made with waterproof connections, so of course I can't get at them. So if we get down there, I'm going to have to cut some of the wires so that I can test and see what's going on. First thing to do is I'm going to check this voltage, see what that is, see if it's near to 12 volts, because if it's lower than that, especially when the pump is operating, then I know that there's a loss in one of these wires. Then I can check the switch, this wire, and then I can check this fuse as well. But if when the pump is operating I've got the same voltage here and here, then I can be pretty sure that this switch and this fuse are doing their jobs properly and they're acting as perfect conductors. So let's have a look at that first. Here's the switch panel, which I am in the process of replacing, although that's another story, a story for another day. I've connected one end of the multimeter to the positive and the other end to the negative, and you can see that I am getting 12.28 volts, and I've got this little USB charger outlet, and that's reading 12.3, so you can see that that tallies pretty well. So that's just the voltage that I'm getting when the pump isn't operating, because the float switch isn't pushed up enough to turn the motor on. So what I've done now is I've reattached this, the positive, to the positive bus bar, and I'm just going to operate the float switch like this, just by pulling it up. And then let's see what happens to the voltage. So it does drop a bit, so you always expect that, because it's whatever voltage source you've got. Normally it would be a battery, but in this case I've got a 48 volt to 12 volt converter. Is always going to drop a little bit because it's got its own internal resistance. I'll let go again, and you can see it goes back up to 12.28. So that's so really what we're looking for is, if this switch here is perfect, then we should see 12.28 on there as well. Let's have a look at that. So 12.28 at the moment. I'm just going to lift the float switch. Now we've gone down to 11.88. So we've got quite a significant drop across this switch, which is very interesting. Back to 12.28. Let's have a look to confirm that. Connect to there and there. Okay. So 0 volts when voltage drop, when there's no current flowing, but when there is current flowing, there we go. We've got 0.3 volts. Okay. So here's an interesting check. What I've done is taken out the fuse and I've connected the multimeter across the fuse terminals, and I have changed the settings on this so that I'm on the 10 amp setting, and you have to move the plugs so that you are in the 10 amps, the amp measuring setting as well. Probably a bad idea to try and measure a significant current without moving it, because this standard one, so if you leave it plugged into there, it's only 200 milliamps. And I have looked up this pump, and it's supposed to draw 2.5 amps off 12 volts when it's working properly. So let's see what current the pump is drawing at the moment. If I lift the thing, there we go. So we're only getting 0.45, 0.46 amps. So it's not surprising that the pump isn't working properly. And if we take a look at it, do this and lift, you can see it is going round. It's just not going round very quickly. And in fact, normally when this is running properly, if you do that, you can hear it. You can even hear it when the floor is down. It's quite audible, not loud, but it is audible, and you really can't hear it at all there. So obviously something is wrong. Okay, I have just started tracing the wires for the pump down. So this is the wire. You can see it attaches to the bottom fuse, traces down, it goes round in a big loop and eventually ends up going down here. And as you can see, this is not wiring that I did, but we've got, looks like a joint which is made just with some electrical tape. I'll just stop this while I take the tape off, and let's have a look at what the joints look like. Well, will you look at this? This joint is just twisted together, and you can see that nasty green colour. That means that this is not good at all. Let's have a look. Yeah, so I certainly think that the first thing I need to do is replace this with a proper solder joint using one of the waterproof connectors that I've got. Let's have a look at the other one too. But this would be good because I can do a quick test to see whether this is the cause of the problem. So what I'll do is I need to cut back here until I can find some good quality copper, and that means I can use that to see if this is where the problem is or it's further down the line. Right, I'll be back in a mo. Right then, so this shows you why it's so important to have waterproof joints. See, this should be a bright shiny copper colour, and you can see it's absolutely black, so that's corrosion there, which is not helping things at all. And I had to cut back probably 20-30 centimetres in order to, no more, in order to get back to decent copper. What I'm going to have to do now, which is really annoying, is I'm going to try and pull this piece of string through under here, because if I have to take this piece of the cabin sole up, that'll be an absolute nightmare. So I've got to try and pull that through here now, and hopefully that will allow me to pull 2 new cables through, which will let me redo the whole thing. And it's raining nice and heavily into the cabin. Right, so I've got this piece of string attached to the end of the first cable, so I'm now going to pull it through. Hopefully it won't snag on anything, and that'll enable me to pull a couple of new cables through. Here we go. Well, that was good. A couple of heart in mouth moments, but yes, I've managed to pull it through. So I just need to pull a couple of fresh wires through now, and that will enable me to rewire this up properly. That's great news. In order to make sure that I've found where the problem is, I've actually disconnected the pump completely, and what I'm going to do is connect it directly into the 12 volts via the multimeter, so I can measure the current going through. Let's do that now. So the positive goes over to the positive there, and then the negative I'm going to attach to the positive lead of the pump, and then I've got negative of the pump going through to the negative bus bar on the switch panel. So if I turn this on now, turn it around to 10 amps, and make sure that that's in the 10 amp connection. Yes, it is. And then turn this switch on. So you can hear it's going really fast now. Still only getting half an amp. Seems a bit weird, but it is definitely going a lot quicker than it was before. So that looks good. It may be that this connection is not that great, and when I put a proper connection on, then I'll get more current flowing, but it's definitely going fast. Next thing to check is the float switch. Now, I've had a look at this wire, and really it's still very corroded, so I've cut this back quite close. So I think I'm actually just going to have to replace this entire float switch. Now, I think I've seen that I've got a spare, but if I haven't, there's a Chandler's in town, so I can go and get one. It's now about a week later, and I have received this courtesy of eBay. New float switch, And if you compare it with the old one, pretty much the same size. This is the RS14, which you don't seem to be able to get anymore. I'm guessing it's that first sentence is probably the key to why it's no longer sold. Switch within contains mercury. So I now have this new one, which is I think mercury free. It clicks rather than being smooth. And let's see what the difference is between the old one and this one. So I have, this is a bit of a mess. So I have connected both ends of the switch. So the two wires that are coming out of the switch I've connected to the positive and the negative. So if I turn this round so that it's on the minimum resistance, you can see that that just means that effectively there's no connection between the two wires. Now if I lift the float switch, okay, you can see that it's reading 130, around 130 ohms. Yeah, it's a bit variable. So this is way too high. Let's see what the new switch looks like. So I'll take it off there and off there, connect to there and there. Now when I click the switch, there we go. Okay, so that's gone down to 0.4 ohms. That is as good as, oh, even 0.3. That's as good as you're going to get. In fact, what I'll do is I'll show you what happens when you connect the two wires together. So if I connect these two leads directly together, okay, as you can see, it's about the same resistance. So that means that this float switch and the wires aren't adding any more resistance into this circuit. So that means that this is working perfectly. So you can see that replacing this with this new one should make a big difference. First thing I need to do is run a wire down through that hole and then underneath the cabin floor and out here. So what I've done is I've attached the wire like that to the string, and I haven't cut the string because what I want to do is make sure that I can pull it all through, and if it gets stuck halfway I can pull it back. So this is going to be the first one. I'm using 17 amp wire, which is well overkill, but the fuse which is there is a 5 amp, so you always want the fuse to be the thing that's going to go first, so otherwise your wire would melt and burn, which could be quite toxic before the fuse went. So the 17 amp cable means that the fuse is going to be the first thing in the circuit that will go. Right, I'm going to see how this goes now. So that's worked really well. That's come straight through. So I'm just going to make sure that I've got all the lengths right, and then I will run the red wire through. That's the second one run. I'm going to leave this string in place to make it easier if I need to pull some more wires through. So I now know how much I need, so I can do that and tidy all that up. In the end, I've decided to change both the pump and the switch because the wires for the old pump still look very corroded. So I think that it's best to just do the whole lot. The good thing is both the pump and the switch have got like detachable bases, so it makes them really easy to put in place, and it means also that I'll be able to wire it all up before I clip it in without danger of getting everything wet. It may not look like it. I have actually cleaned this with a grime remover, but you can see how filthy it all was. Once I get out to sea, I'm going to do like a bit of a bilge cleaning thing, but yeah, I don't think that this is ever going to be great. Right, I should have done this before I cut the wires actually, but I'm going to, before I do anything else, test that the pump actually works. So I have wired the brown wire, the positive, into after the fuse, and I have wired the negative into the negative bus bar. So if I flick the switch over here, there we go. You can hear it going and whirring round now. I'm using these heat shrink connectors, which have got a low melt point solder, which are really good, and they're waterproof. But the disadvantage is, once you've done them, you can't test them. So at each stage, I will test through to make sure that the connector works. So this is connecting us from the positive here at the end of the fuse through to the switch. So if it all works, the other end of the switch should be directly connected to the fuse when I lift the switch up. So I'll just take the end off here so that I can get at it and do that test now. So I've got one end of the multimeter connected to this one beyond the fuse, that's the positive wire, and then I've got the other end connected to the other side of the float switch, and you can see I've got it set to resistance, to the lowest value. So when I lift the float switch, you can now see that the value is, yep, that's 0.4 ohms. So that means that it's working properly, and that I have made this joint properly. If this was a bigger value than that kind of 0.4, less than an ohm anyway, then you'd know that there was a problem with this connector and I'd have to redo it. Now the next stage is connecting the output of the switch to the positive of the pump, the brown wire on the pump. Now once I've connected that, the only thing that I can get at is actually on the negative of the pump. So I'm going to be measuring through the pump itself. So in order to make sure that I know what I'm looking for, what resistance I'm looking for, I'm going to measure the resistance of the pump itself before I do the connection. So I've got one wire connected here to the positive. I've got the red connected to the positive wire, but it doesn't really matter because these things should be a resistive load when they're not turning. And then the other one is now connected to the negative. And if I have a look, you can see that it is just under an ohm. So if I get anything that's around about 1 ohm, 1.2 ohms, when I make this connection, then I should be okay. I should have done it properly. Right, I'm just about to make this next link, and what I've found is it's much better to make sure that the two ends of the wires are pinned down so that when this gets hot it gets softer, and if you just got them kind of in the air you can get the whole joint distorting and it doesn't make so well. This stuff here is a heat-proof matting, so when I put the heat of the heat gun on it, it's not going to scorch the cabin floor. Okay, so the joint's made now, so let's test that the joint's been made properly. So once again, I have connected the positive of the multimeter to the fuse end of the supply. Then I've gone down and the negative end is connected to the negative of the pump, the black wire. So, and I have set it to 200 ohms. So when I lift the float switch, let's see what happens. And there we go. We've got a voltage of 1.4, 1.3. So that is kind of what we expected, 1.2. So we expected it to be just over an ohm, which is the resistance of the pump itself. So it looks like that's working. Right, this time we're connecting from the positive supply just after the fuse, and then we're going right back to the main negative bus bar. So let's see what's happening. Turn the multimeter on and then lift the float switch. Okay, and there we go. That resistance now 1.1, 1.0, so we've got a very good connection right through the circuit. So the only thing that remains is to switch it on. Right, let's have a go. I'll just take these clips off and there's the pump. Switch it on and then lift the float switch. And there we go. It works beginning to end. So most of the time that would happen anyway, but of course if I had just wired it all up and it hadn't worked, I wouldn't know at which stage that I'd made the error, and I'd have had to start again or kind of guess. So this way, doing it one by one and testing each bit as you go means that you've got much more chance of finding out if you've made an error in connecting it up properly. This is a final connection I've just made, which is from the negative of the pump through to the negative which is connected to the bus bar. I've tidied up the wiring, so just running it round so it's all neatened. Some of you might wonder why I've done this loop here, and the reason is that I wanted to keep this joint as high as possible so that it doesn't get wet. These are supposed to be waterproof connectors, but I don't want to take any chances. So that's why I've run these high. Also, I've left these loops in just in case I need to take it apart and rewire it, because inevitably if I'm going to cut these joints I'm going to lose a bit of length. So this gives me the opportunity to kind of replace bits at least 2 or 3 times. The eagle-eyed amongst you will have noticed that there's a zip tie around the pump. So that's my fault. I was trying to get the pump off its mounting base and I've broken one of the tabs. So the zip tie is holding the pump in place now. I can't see that there's going to be a problem. I've connected the output of the pump through to this pipe, and I have done a quick check just to make sure that it all looks like it's connected out to the outside of the boat. So the next thing is to put some water in and see if it actually pumps. So you can see that it's now working. There's a bit of a leak at the front where that pipe joint is. I need to sort that out, but it is pumping it out really quickly. So yeah, it's working a lot better than the old one was. And there we go, it's pouring out. The old bilge pump, even when it was working properly, it only used to trickle out there. So yeah, that's a great improvement. Well, that seemed to go pretty well. I went through that in quite a lot of detail, and I hope that that was useful for you. I think the key things to take away is when you've got an electrical problem, start by actually tracing through the circuit. So where does it start from? You know, right from the battery positive coming right round through the thing that's not working. You know, in this case, it was the pump, could be, you know, a radio or whatever. And then coming back to the other end of the battery negative. If you kind of draw that out literally as I did, and then said you can test the voltage at various points along the system, and then if you can test the resistance of various parts of the system, you can start to narrow down where the problem is. And in general, what you're trying to get is there's going to be all of the voltage as much as you can get. So 12 volts normally, but 24 volts with newer systems, that's going to be across the thing that you want to be working. So I wanted the full 12 volts across my pump. You know, if it was a VHF that wasn't working, you want the full 12 volts to be applied to the VHF radio. So you can take it step by step, going round and round the system. And as you can see, what I found in the end was that the pump was okay, but it was actually the switch that was faulty. Even though the condition of the wiring wasn't helping by any means. So in the end, I replaced the whole lot anyway. But, you know, if I'd been in a situation where I was out at sea and I didn't have those spare bits, I could have kind of bodged something up probably, you know, so I could have got rid of the float switch, wired the pump directly to the 12 volts, and then just turned it on and off when I needed to. And I would have been able to do that because I'd gone through the circuit from the battery positive right through to the battery negative again. So I hope you, as I say, I hope you did find that useful, and you know, maybe one day I'll actually do some sailing, but in the meantime, I'll see you again soon.